Hello, the Math Dog here. In this video I am going to derive the quadratic formula, which is a formula that can be used to solve any quadratic equation. It's a little intimidating to a first year Algebra 1 student or 8th grader or even older students, but I believe it's worth showing where it comes from, because it is, if you know how to complete a square, you actually can derive the quadratic formula. Although because we're using variables, numbers instead of constants, it's difficult for a lot of people to see initially because it looks very abstract. This video is not to be shared or reproduced without the written consent of the creator, myself, the Math Dog. So let's get started. So the quadratic formula states that for any equation of the form ax squared plus bx plus c equals 0, a not being equal to 0, x equals negative b plus or minus the square root of b squared minus 4ac all divided by all over 2a. So this formula can be used to solve any quadratic equation. So we did see, for example, when you have factoring using integers, there are certain equations and functions that cannot be factored over to integers. You can solve any quadratic equation using the complete the square method, but the quadratic formula is usually much faster if you have to do that. That being said, if it's a simple equation, if you can, just take the square root of both sides. You can't always do that, because if you have an x squared and an x term, you can't do that. And also, if it just can be factored simply, just do that, because the quadratic formula is a little more involved than just if you can see how to factor something, just do it. Alright, let's get started. So we use the complete the square technique to derive the formula. Actually, as I just mentioned, the completing the square method can solve any quadratic equation, but we're coming up with a general formula here. So a is a coefficient of x squared, b is a coefficient of x, c is a constant, b cannot be, actually it should be a not 0 here, not b. The reason that is because it's not a quadratic equation. If a is 0, it'd just be bx plus c, and that's now a linear equation, so that would not apply because you just have bx plus c. So the proof, we start with ax squared plus bx plus c equals 0. So to complete the square, first of all, you isolate the x squared and x term. So I'm going to subtract c from both sides. That's going to be my first step. So now I have ax squared plus bx plus c, those subtract out, c minus c is 0, so I have equals negative c. The next thing we talked about when completing the square is the x squared term must have a coefficient of 1. So my next step is going to be, I am going to divide everything by a. Okay, so now I have x squared plus b over a times x equals negative c over a. So now I can complete the square. So this is difficult for students to see at first because it's kind of abstract, but let's think about completing a square. How did we do that? So if I had x squared plus 4x to complete the square, I took half of 4 and then squared it. So that's 2 squared is 4, so I added 4 here. If I had x squared minus 6x, I took half of negative 6, which is negative 3, and then I squared it, which makes 9, so I would have put 9 here. So when I factored these as perfect square, as binomial squared, this was x plus 2 squared. I'm getting that 2 right there. And then this would be x minus 3 squared, and I'm getting at negative 3 here. So let's take a look at this. So I'm going to take half, so in our problem here, I'm going to take half of b over a, because I'm following the exact same procedure I did with these, okay, which is b over 2a. Then I square that. That's how I complete the square. So I have that, okay. So we're going to add that now to both sides. So we have x squared plus b over ax plus b over 2a quantity squared equals, I'm going to have to bring this down here, I'm out of room, negative c over a plus b over 2a quantity squared. Because what I do to one side, I have to do the other side. So now, this factors as a binomial squared. This would be x plus b over 2a squared equals negative c over a plus, I'm going to write this now as b squared, I'm going to square this out, that's b squared over 4a squared. Okay? So just to show you that in fact x plus b over 2a squared gives you what we started with when we completed the square, that it gives me this. Let's actually multiply it out using the box to demonstrate that I'm not just making this up. Actually, you can reason this out. So that's x squared, that's b over 2a x, that's b over 2a times x, and that's going to be b squared over 4a squared. Okay, well, b over 2a times x that gives me, that's going to be 2bx, because I have 2bx's here, over 2a. My common denominator is 2a. The 2's cancel, so I'm left with b over a times x, which is what I had here. And b squared over 4a squared is in fact this. So we just demonstrated that in fact when we factor this like this, we get this. So we're good for now on the left side. So let's rewrite this. I have x plus b over 2a quantity squared equals, now here on the right side I'm to get a common denominator, so I can make one fraction. But my least common denominator of a and 4a squared is 4a squared, because I can multiply a by 4a to get 4a squared, so I have to do the same to the numerator. So I have that. Okay, I'm going to leave the left side alone for a moment, so I'm just going to copy that down. And the right side, I have a common denominator now of 4a squared, so I have negative 4ac plus b squared, and I'm going to swap these. So I'm going to write this as b squared minus 4ac over 4a squared. So now I have x plus b over 2a quantity squared equals b squared minus 4ac over 4a squared. Well, I want to solve for x, so now to get rid of square, I take the square root of both sides. Okay, so on the left side now, this becomes the absolute value of x plus b over 2a equals, the right side, I'm actually going to write this as two radicals. I can do that, b squared minus 4ac over the square root of 4a squared. Okay, so now I'm going to remove, and I'm going to simplify this in a moment. So now I remove the absolute value signs, and if you remember from solving quadratics, we have to write this as plus or minus the square root of b squared minus 4ac over 2a. I'm sorry, square root of 4a squared. Okay. Well, the square root of 4a squared is going to be plus or minus 2a, but I already got a plus or minus here, so I can just write it as 2a. Because even if it was negative, it still got a plus minus here, so I don't have to go with like the absolute value of 2a and then remove the sign, put a plus minus. I mean, technically, I guess we could do that. So the square root of 4a squared technically is the absolute value of 2a. So we have plus or minus the square root of b squared minus 4ac all over absolute value 2a. So we got x plus b over 2a equals this. Well, when I remove the absolute value sign, it's going to be plus or minus 2a, but I already got a plus or minus here, so I can just keep the one plus or minus. I don't need two plus or minuses here. So this becomes b squared minus 4ac over 2a, and now x plus b over 2a equals this. So now solving for x, I subtract b over 2a from both sides, and I get x equals, I'm going to put this first, negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now my last step, I have a common denominator of 2a here, so I can put a 2a in the common denominator as my common denominator, and I have negative b plus or minus the square root of b squared minus 4ac, and there is the derivation of your quadratic formula. And this concludes the video.